Testing, testing. Testing. Hello, everyone. Can you hear me? If you can hear me, please type yes in the chat box so that I know that you can hear me. Okay, wow, fantastic. Let's wait for a while more before we begin the online lesson. Well, maybe for a start, you want to introduce yourself? Yeah, tell us what's your name and what school are you from for all the students out there. You can type in the box so that we can know, yeah, we can know more about you. Wow, CHIJ, Mary Stella, Yuming, Gongsan, Mito. Okay, maybe you can see if you can find your classmates here. Singapore is very small. Maybe hopefully you can find one of your friends over here. You never know. Townsville. Wow, okay, that's my primary school last time. We have one person from Townsville. Okay, the time is now 8:30. I think we shall begin the lessons. Okay, so thank you so much for your introduction. All right. For those who still can't see the video, please refresh the browser and you'll be able to see the video and watch and hear my voice. Okay, welcome everyone. My name is Jimmy. I'm from IntelliCat Tuition School and I specialize in teaching math. Okay, so I believe your P5 exam is coming. It's around the corner. Am I right? Anyone exams over already? Well, I believe not yet. Or if your exams are over, then I'm afraid this video may be a bit too late. Okay, but you can still apply it to your next to your P6 lessons next year. Okay. Okay, you can actually adjust the video qualities. All right, in this button over here. Okay, but I believe you can see me clearly, right? So it should be okay. Even if you can't stream the video properly, let's say your internet is down or whatever reasons, right? Okay, don't worry. At the end of the lesson, I will actually email all of you the link for these lessons. Okay, you can watch it anytime you want, all right? Okay, thank you so much for your introduction. It's so glad to see so many students from all over Singapore in this lesson. And I hope that what I'm going to share with you tonight is going to be very useful for in your coming out exams. Okay, some rules. No spamming the chat box. Okay. Please pay attention. All right. You're supposed to watch a video and pay attention to what I say and not typing furiously in the chat box over there. Still can't see me. No, you're not supposed to see me. All right. You're only supposed to hear my voice and watch the lesson. Okay. You're not supposed to see my face. Okay. If you have any questions, feel free to type in your question in the chat box, and I'll try my best to answer at the end of the lesson. Right, but take note that there's about 1 or 2 minutes of lag. Okay, so I may not be able to see your questions immediately. And of course, when I'm teaching, I mean, you're here already, so don't waste your time. All right, no surfing of Facebook, Instagram, or playing Minecraft and Clash of the Clans. Right, so pay attention to what I teach. Okay, what is the objectives of the lesson today, right? Today we are going to do some revision, all right, especially on paper 2 on the problem sums, okay, because I believe that's a part where most of the students are very weak in, okay? And I will also teach you how to check your answers, okay? Most students get careless mistake, all right, because they didn't know how to check their answers. I'll also go through some common mistakes that you have to avoid. All right. And also, last but not least, I'll go through some time management skill, all right? Because a lot of students complain that they got not enough time to finish a paper, right? It's either you have too much time or you not enough time. If you have too much time, it may be a good thing, it may be a bad thing, right? If it's a good thing if you can do all the questions and you have a lot of time left, but it's a bad thing if you can't solve many of the questions. So I hope you belong to the good thing over there, right? Okay, so let's get to the point, right? So we're going to go through some methods which you must know, right, in order to solve a problem sum. Okay, method which you must know. Okay, first of all is a model drawing. Right, model drawing is a very useful method because it helps us to visualize questions in a very clear way. Okay, so when do we apply a model drawing? Okay, you apply model drawing when you see problem sums with fractions especially. All right. So basically, if let's say for example, if Ahmad use 1/5 of his money, right, you can actually draw a model and cut it out into 5 units, and so he can use 1/5, right? So it actually gives us a very clear way of seeing the problem sum, right? Actually, how can I see the video? You need to refresh. If you still can't see the video, means. Okay, so that's for model drawing. Okay, for constant part, constant total and constant difference. Okay, let's talk about constant part first. Okay, these type of questions, right, is applied for questions that involve ratios. All right, very importantly, ratios. Okay, so when do we apply constant part? Okay, constant part is when you have, let's say for example, a ratio between A is to B. Okay, and one of them changes. Let's say for example, A increases while B stays the same. Okay, this one stays the same. So this is when you apply a constant part. Okay, and for constant total, okay, constant total is when you have an internal transfer. All right, what is internal transfer? Internal transfer means from A, you transfer a part from A to B. Okay, I'll be going through some of this question later on. All right, so when A transfer some part from A to B, all right, of course, the total stays the same, right? Because when A decreases, B will increase. Correct. So when you see questions that involve an internal transfer, all right, the total stays the same. In this case, it's called constant total. Okay. Then for constant difference, okay, constant difference means A is to B. Okay, A increases and B increases by the same amount, right? Same amount. This is called a constant difference. Okay. Of course, other than increase, they can be decreased, right? It can be A or B decreased by the same amount. That's also called a constant difference. Okay. One very common example of a constant difference would be age, right? For example, age. Okay, age is an example of constant difference because why? Because our age difference, right, is always the same. Okay, when A grows old, B also grow old, right? B can't be growing younger, right? So that's why the age difference between A and B is always the same. Okay, so when you see problem sums that involve age, right, you should know that you are dealing with constant difference. Okay, the third method is called guess and check. All right, I'm sure you have learned this before. Guess and check is when you need to guess some values and check your answers, and you keep on guessing until you get the correct answer. Okay, but later I'm going to share with you a faster way to do the guess and check. Okay, which allow us to make some assumptions. Okay, I'll be touching more on this later, right? You can actually make some assumptions to do the guess and check faster. Okay, next method is called grouping. Okay, grouping, as you all know, means you have to group up the sets, right, into different groups. Then from there, right, for example, you can group up 50-cent coin, right? 50-cent coin and a $1 coin together, for example, right? Just a simple example. So those similar items will be into one group, right? Then from there, you can work out a problem. Okay, and the last but not least, work backwards, right? This method is when you're given the final conditions and you need to work backwards to find the initial conditions. Okay, so I'll be going through some problem sums that actually uses each of these method. Okay, so let's look at an example of model drawing. Okay, before you read when you read the question, okay, I'm going to teach you I'm going to give you some useful tips. Okay, it's very good to underline the keywords when you're reading the question. All right. Okay, why is that so? Because you help us to save a lot of time. Okay, because the keywords are the words that give us the information. Okay, example of keywords. Okay, Mary has seen number of red, green, and blue beads at first. Okay, in this case, red, green, and blue. All right, these are three keywords that you must know. I mean, Mary, okay, and the same number. Okay, this is also a keyword, right? Same number. Okay, at first is also keywords. Okay, you see, by just underlining the keywords, you're able to know that at first means initially, at the start. All right, Mary had the same number of red, green, and blue. Okay, so these are the important keywords. Okay, after using some, okay, some, red and green, you don't know how many beads does Mary use. You only know that Mary uses some. And 1,108 blue beads to make necklaces. Okay, I don't think necklaces is a keyword. Well, you can use the beads to make anything you want. Right, in this case, it's not so important. But just keep in mind that Mary uses some red and green, but for blue, you know that it's 1108, right, to make necklaces. And you're given the final condition, right? The final condition is Mary had 4250 bits left, right? In particularly left, right? That means the leftover is 4250. Okay, and there were twice as many red as green left. Okay, so in the end, the red bits is twice of the green bits, and the number of blue bits left was 680 fewer than the number of red bits left. Okay, so yeah, so towards the end, the blue bits is 680 lesser than the red bits. And the question asks, how many red bits did she use? Okay, so these are all the keywords that we should think note of. Huh? Okay, why you underline the keywords is because when you read back the question, you can avoid reading those unnecessary words and just focus on the keywords. Okay, so this question is about model drawing. Of course, there are other methods of doing this. I'm sure you can, for those students who have other methods, please go ahead. But for this, I shall go through a model drawing. And this question also apply working backwards because you are given the final results. You need to find the initial or how many red bits you use. All right, so let's draw a model over here. So at the end, okay, for red is twice, right? Twice as many red as green, okay? So for red, you draw 2 units. And for green, you draw 1 unit. Okay, is that clear so far? Right, because they were twice as many red as green, right? So red is 2 units and green is 1 unit. Okay, the number of blue bits left was 680 fewer than the number of red bits. So for blue bits, is fewer than the red bits by 680, okay? We do not know how long is the blue bits, right? But it doesn't really matter, okay? You can just make a guess, okay? In this case, let's say the blue bits is over here. I mean, of course, I won't know whether my blue is more than my green, okay? But it doesn't matter, okay? Later you will find out why, right? Because we only need to care that the difference between the blue and the red from here to here is actually, oops. Okay, the difference from here to here between the red and the blue is actually 680. Okay, that is what we care about. All right. Okay, the rest is not so important. Okay, we only know the difference between the red and the green is 680. And the question also says that the total bits left is 4250, right? So from here to here, the total is 4250, right? There are 4250 bits left. Okay, so you see by drawing a model, it gives us a very clear picture, right? To find the find the red, green, and blue respectively. Okay, so since from here to here is shortage of 680, right? You work backwards. You take 4250 plus 680, okay, to fill up the gap here. Do you get what I mean? Okay, let me repeat that again. Because 4250 is shortage of this 680, right? It doesn't include this 680. So if you plus the 680, you will fill up the gap over here. All right, so that's my first step. So 4250 plus 680. Okay, this is a paper 2 question, so you can press your calculator. All right, it's a 4930. Okay, so 4930 is including the gap over here. And 4930 will stand for how many units? Okay, let's count. We have 1 over here, 1 unit here, 1 unit here. And this whole thing here is equivalent to the red color one, right? So from here to here is actually 2 units. Make sense? Because I've added a 680. So this whole thing is same as the 2 units over here. So from here, we can see that 1, 2, 3, 4, 5. 5 units will represent 4930. Okay? This is 5 units. And from here, I think it's pretty straightforward. You can find 1 unit. You'll get a 986. Okay? And now, okay, I bet the question. Okay, let's go back to the question. The question asks for how many red bits did she use. Okay, so to find the red bits that she used, okay, you can times 2 first. Okay, to find the final red bits that she have at the end. So 2 units will be 986 times 2, so it's 1972. Okay, 1972. This is the number of red beads that she have left. And because the blue beads is 680 lesser than the red beads, you can take 1972 minus 680. All right, so you get 1292. Right, this is the blue beads left. Okay, so 1292 is over here. All right, this is the number here, 1292. Okay, 1292 is now 1292 is the number of blue beads left. Okay, so how do I find the total red beads at the start? Okay, remember the keywords. Let's go back to the question again, right? Mary had the same number. Okay, that means at the start, the red and the green and blue are all the same. Okay, and we can find the number of blue beads at the start. Okay, because we are given how many blue beads she used, right? So we simply take 1292 plus 1108. Okay, and you get 2400. Okay, this is the number of red, green, or blue beads at the start. Okay, red, green, or blue because they are all the same number. All right, and finally, to find the number of red beads that she used, you simply take the number of red beads at the start minus the number of red beads at the end. All right, and the end is this one, right? 1972. Okay, and so the final answer is 428. All right, so this is the example of a model drawing. Okay, if you have problem understanding what I just said, you can always feel free to rewind. Okay, you can always, in your browser, you can always feel free to rewind the video and watch again. All right, to make sure that you understand what I said. Okay, so this is a model drawing. Let's go to the next example, which is on a constant part. Okay, remember for constant part, I said just now, one part remains the same, right? So let's look at this question. Okay, there were 378 chairs, and the number of white chairs to the number of a gray chair was 1:5. Okay, the teacher then increase the keyword. Okay, the number of a white chair, so the number of white chairs to the number of gray chair become 3:7. Okay, and the question asks how many white chairs were added. All right, so this is an example of constant part because when the teacher increased the number of white chairs, the gray chair remained the same. All right, so that's why it's a constant part, right? The gray remain constant. Okay, so for this question is I think it's the best to use a ratio to do. Okay, so at the start, white is to gray is 1:5. Okay, and in the end, white is to gray is 3:7. Okay, so remember the gray chair remain the same, right? So I need to make this number and this number here the same. Okay, so to do that, you simply times 7 over here and here times 5. Okay, I want to make the gray chair the same. Okay, so 1 times 7 is 7, 5 times 7 is 35. And for here, 3 times 5 is 15, 7 times 5 is 35. All right, can you see that the gray now is the same? All right. Okay, so from here, we can find one unit. Okay, 378 is a total, right? 378. Okay, so 7 plus 35 is 42 units. So 42 units is 378. Okay, and the question asks for how many white chairs were added. Okay, from here you can see the increase. Okay, the white chairs increased by how many units? In this case, it's 8 units. Right, 15 minus 7 is 8. The white chairs increased by 8 units. Okay, so to find the number of white chairs added, you simply find 8 units. Okay, let me teach you a shortcut to find this. When you see a question like this, you simply take 378 divided by 42 times 8. 378 divided by 42 times 8. Okay, you will straight away find 8 units. And the answer will be 72. All right, so this is the number of white chairs that were added. Okay, so this is an example of constant part. Constant part means one of the part remain the same, right? Keep in mind. And so when you do question with constant part, you have to make one of the ratio the same as the other part, right? Because in this case, the grade remains the same. All right, so this part over here has to be the same as this part over here. All right. Okay, so this is for constant part. Okay, next one we are going to do a constant total. Okay, remember just now what I said? For constant total, you have questions that involve internal transfer, right? That means from A you transfer a part to A to B, from A to B. So the total stays the same. Okay, so this example, the ratio of a team marbles to Sherry's marble was a 7:5. Okay, after team had given 36 marbles to Sherry, okay, the ratio of a team to Sherry is became 1:3. Okay, so team give away 36 marble, right? So team marbles decreased by 36 and Sherry marbles increased by 36. Okay, so the total is the same. And the final ratio is 1:3. Okay, so this is what you do. Team is to Sherry is 7:5 at the start. Okay, from here you find a total. Okay, because remember the total stays the same, right? So I want to find the total units. So this case is 12. Right, 7 plus 5 is 12. Okay. Okay, then for the final ratio, okay, it's 1:3, right? So team is to S. Okay, this is towards the end, okay? Towards the end, the ratio is 1:3. And the total is 4 units. All right. Okay, so remember, for this question, what did I say? The total stays the same, right? The total remains the same. So I need to make this number the same as this number. Okay, that means I need to make the 12 the same as a 4. So to do that, you simply take 4 times 3, right, to get back 12. Okay, so 1 times 3 is 3, 3 times 3 is 9, and 4 times 3 is 12. Okay, so this is the ratio towards the end. All right, so from here you can see very clearly team drop by how many units? 4 units, right? While for Sherry, she increases by how many units? 4 units. Okay, so team drop by 4 units and Sherry increase by 4 units. That's why the total stays the same. Okay, and these 4 units will represent the 36 marbles, right? Because team gave 36 marbles to Sherry. Okay, so from here we can find 4 units is 36. Okay, and let's go to the question again. The question asks for how many marbles did Sherry have in the end? Okay, I forgot to underline the keywords here. All right, Sherry have in the end. Okay, common mistake. Okay, a lot of students take this number instead. That means they simply take 36 times 3. Okay, you shouldn't do that. Okay, because what is wrong? Because you have already converted the fraction, right? You have already changed the fraction. So you should always use this number instead. Okay, you should use the final number and not the one that you before you convert, or you should use the one that you have converted. Okay, you should use the 9 units over here. Right, this is the Sherry's marbles in the end. All right, so to find 9 units, all right, you simply take 36 divided by 4 times 9. Okay, 36 divided by 4 times 9. Okay, and 36 divided by 4 is 9, 9 times 9 is 81. Okay, so the number of marbles that Sherry have in the end will be 81 marbles. Okay, so this is for constant total. All right, so once again, let me emphasize again, constant total means the total must stay the same. So you must make the total here the same as the total over here. All right. Okay, next example, grouping. Okay, grouping. Okay, grouping means I need to arrange them into groups. That's why it's called grouping. Okay, and Ali brought some shirts and shorts. Okay, Some shirts and shorts. You don't know how many, right? Some, right? Okay, the shirts were sold at 3 for $12. Okay, that means the 3 shirts were sold at $12, right? You need to group the 3 shirts together as one unit. And the 3 shirts in total were sold for $12. And the shorts were sold for 2 at $6. Okay, the shirts were sold for 3 at $12, and the shorts were sold at two for $6. Okay, if you spend $546 on an equal number, right? The keyword is equal number on of shirts and shorts. Okay, he spent $546 in total. All right, on an equal number of shirts and shorts. How many shirts and shorts did he buy all together? All right, so this is a question mark. Huh? It's a typo. Okay, so how do we do this question? All right, okay, we know that the shirts were sold at 3 for $12, and the shorts were sold at 2 for $6, right? And he also spent on an equal number of shirts and shorts. Okay, so in order to sell an equal number, you need to find the lowest common multiple between 3 and 2. All right, because it's an equal number, right? So I need to find the lowest common multiple between 3 and 2. Right, because I want to group this together as one group by itself. Okay, so the lowest multiple between 3 and 2 is 3 times 2, right, which is 6. Okay, 3 times 2 is 6. All right, so in this case, let's group 3 shirts and 3 shorts together. Okay, so let's group in this case shirt 6 shirts and 6 socks together. All right, let me repeat that again. So you group them up. So one group is equivalent to 6 shirts and 6 shorts. Okay, why do you want to do that? Okay, because first of all, we know that he spent 546 on equal number, right? So the shirts and shorts must be the same. And why 6? Okay, because 6 can be divided by 3, and 6 can also be divided by 2, right? 6 is a common multiple, okay? So this is what we do, right? We group 6 shirts and 6 shorts together as one group. And we find the total cost of this group. Okay, that's the key, right? You want to find the total cost of this group. So how do we do that? Okay, 3 shirts were sold for $12, and one group got 6 shirts, right? So 6 shirts will cost how much? You simply take 12 times 2. Okay, the reason is because 3 shirts were sold for $12, right? And you want 6 shirts, so you simply take 12 times 2 to give you the $24. This is the cost for 6 shirts. And 6 shorts will be $6 times 3. Okay, why? Because 6 divided by 2 is 3, right? You want to find the cost of 6 shorts, so you take $6 times 3, so it's $18. Okay, so this is the cost for shirts, and this is the cost for 6 shorts. So now I can find the cost for one group. All right, so one group, you simply take this amount plus this amount, right? This is the cost of one group. So you take $24 plus $18. All right, this is the total cost of one group, and this will be $42. $2, right? This is the total cost of one group. And to find how many groups are there, okay, in total, right? You simply take 546 divide by the cost of one group, right? Because one group costs 42, right? And the total is 546. Okay, so you get a total of 13 groups. Okay, so there are 13 groups, and one group has a 6 shirts and 6 shorts. So the question asks for how many shirts and shorts did he buy all together. Okay, so to do that, you simply take 13 times 6 times 2. Okay, why? Because there are 13 groups, and one groups there are 6 shirts, times 2 because the shares and the shorts are the same. Okay, so the total number of, oops, sorry. All right, so the total number of shares and shorts that he buy will be 13 times 6 times 2 is 156. Okay, so this will be the total number of shares and shorts. Okay, I hope that you understand so far. So this is when you apply grouping, right? Right, grouping is when I want to group them together as one unit. Okay, the next method is called guess and check. Okay, in this case, John brought 48 stamps, and each stamp cost either 50 cents or 65 cents, and he paid $27 in total. Okay, and you need to find how many 50 cent stamps did he buy. Okay, so usually when students miss out a question, you know what's the most usual method that students do, right? They will draw a table. Okay, so they put 50 cent over here, and they put 60 cent, 65 cent over here. Okay, and the total, this is the total number of stamps, and this one is the total value, right? Okay, so you make a guess, right? So 48, maybe you can guess with 24 and 24. Right, total is 48, right? Well, to find the total value, you take 24 times 50 cent plus 24 times 65 cent, right? You get a total value. But however, I find this method a bit too slow. Okay, a bit too slow. So I'm going to teach you a faster method that is some assumption, right? Which I think is much faster. Okay. But of course, if you are more comfortable with this method, please go ahead, right? There's nothing wrong. But today, I just want to share with you a faster method to do the guess and check. Okay, so what do we do first, all right? So we suppose, that means you make an assumption, okay? You suppose that the 48 stamps are all 50 cent coin, are all 50 cent. Okay, that means you suppose that all the stamps are 50 cent and there's no 65 cent, okay? Okay, then we find the total value from here. So the total value will be 48 times 50 cent, you convert the dollar will be 0.5. Okay, you get a total of $24, right? So this is the total value of 48 stamps, which are 50 cent, right? No 65 cent in this case. And of course, this is not what we want, right? Because the total value has to be 27 and not 24. Okay. Okay, so now let's change our assumption. Okay, so now we suppose there are 47 50 cent coin, sorry, 50 cent stamps. I'm too used to saying coins. And one 65 cent stamp. Okay, because 47 plus 1 is still 48. So I'm not actually my assumption, okay? That means 47 50 cent stamps and 165 stamps. Okay, now I find the total value. All right, the total value of this will be 47 times 50 cent. Okay, this is the total value for the 50 cent plus 1 times 65 cent. Okay, and if you press the calculator, right, let me press now, because I'm also doing this on the spot. You will get a total of 24.15, right? This is a total value of 47, 50 cent, and 165 cent. Okay, of course, this is not what you want, right? Because we want the total value to be $27. Okay, but now we can see an important observation. Okay, what is the observation to see from here? When the 50 cent dropped by 1, that means from 48 to 47, and the 65 cent increased by 1, how much did the value increase by? Okay, let me repeat the question again. That means when the 50 cent dropped by 1, and the 65 cent increased by 1, what is the value that what's the difference between these two values? Okay, we see that there's an increase of 0.15, right? Yes. Okay, so the pattern will continue, right? So when the 3 cent becomes 46 and the 65 cents becomes 2, the value will again increase by 0.15, which is 24.3, right? Correct now. Right, I hope that you can see the pattern from here. Okay, so all right, so I want to find I want to get a total, right? Total is $27. $27 in total. Okay, so how many times must this increase to hit $27? Okay, so from here you can apply a concept called big gap divided by small gap. Okay, big gap divided by small gap. I believe this is what some school teachers teach you all, which I think is it actually makes a lot of sense. Okay, so what's the big gap in this case? Okay, the big gap is 27 minus 24. This is a big gap. Okay, so big gap. Of course, in exam, you need to write big gap. I mean, I just write for explanation purposes. Right, you take 27 minus 24, you get $3, right? This is a big gap. And the small gap is 0.15. Correct? Okay, so you take the big gap, divide by the small gap. So you take 3 divide by 0.15. Okay, and you will get answer of 20. Okay, and this 20 represent the number of 65 cent stamps. Okay, why is that so? Let me repeat that again, right? Okay, because the total difference, the big gap between 27 and 24 is $3. And every time the 65 cent increases by 1, the value will increase by 15 cent. Okay, so when you take the big gap divided by small gap, you get a total number of 65 cent stamps. Okay, so this is the number of 65 cent stamps. All right. And how many 50 cent stamps did he buy, right? That's not what he want. Right? He won the number of 50 cent, right? So to get a 50 cent, you simply take 48 minus the number of 65 cent. Okay, so the answer is 28. Right, 50 cent stamps. All right. To me, I find I like this method more than the guess and check, right? Because guess and check, sometimes you have to guess quite a lot of ways in order to get an answer. But by following this, making some assumptions and changing it by a little bit and applying this concept, right, I can find the answer straight away. Okay, so I hope that you actually find this method useful also. Okay, the next method that I'm going to go through is called work backwards. Okay, work backwards means you are given a final answer, final condition, and you need to find the initial. All right. Okay, in this case, Ahmad, Bernard, and Charlie had a total of 240 marbles. Okay, that means this is at the start, right? Okay, at the start. All right. Ahmad gave 25 marbles to Bernard. Okay. Then Bernard gave 49 marbles to Charlie. And finally, Charlie gave 7 marbles to Ahmad. Wow, that's a lot of information, right? So at first, Ahmad gave to Bernard, then Bernard gave to Charlie, then Charlie gave to Ahmad. Okay, and in the end, okay, this is a keyword, right? In the end, they had an equal number of marbles. All right, so towards the no matter, so after all this transfer, in the end, both of them, 3 of them have an equal number of marbles. And the question asks, how many marbles did Ahmad have at first? Okay, at first, right? That's a keyword. Okay, so this is example working backwards. All right, in this case, I'm going to teach you a method called drawing table. Okay, so you start from the end point, this at the end, and I need to find the start. Okay, so at the end, we have Ahmad, Bernard, and Charlie, right? Okay, in the end, they had an equal number of marbles, equal number. And we know that at the start, they have 240 marbles, right? Okay, at the start, it's 240. So remember, for internal transfer, the total stays the same, right? I mentioned before just now, the total stays the same. So in the end, the total must also be 240. Make sense? Right, the total for Ahmad, Bernard, and Charlie also must be 240. And since they have an equal number of marbles, you simply take 240 divided by 3. Okay, to find the marbles that each of them have in the end. Okay, and that's be 80. Okay, so that means at the end, each of them has 80 marbles. Understand so far? I hope you get this clear. This is I would say the one of the most crucial steps here, right? Because if you can get this right, I think the rest will be pretty straightforward. Okay. Okay. Now let's work backwards. Okay. So since we work from back to the front, right? Charlie gave 7 marbles to Ahmad. Okay. So Charlie, to work backwards, you need a plus 7. Okay, because when Charlie gives 7 marbles, you must add back the 7 marbles, right? To find the marbles before he gave to Ahmad. Right? So when he gave away, sorry, the keyword should be gave, huh? Right, when he gave away 7 marbles, you have to add back the 7. And for Ahmad, you need to minus away 7. Okay, so Charlie will be 87, and Ahmad will be 73. And here is the same, right? Bernard is still 80. Okay, do you understand? Right. Okay, let me repeat again. When Charlie gives 7 marbles to Ahmad, okay, to add back the 7 marbles because you're working backwards, Charlie will plus 7 and Ahmad had to minus 7. Okay? Okay, so we are done with here. Now, Bernard gave 49 marbles to Charlie. Okay, so to work backwards, Bernard had to add back the 49 marbles that he gave away, right? Okay, so Bernard plus 49 and Charlie had to minus away 49, right? He got to take away the 49 marbles that he received. Okay, so here will be 73, here will be 129, and here will be 38. Okay, you work backwards. And finally, the last step, Ahmad gave 25 marbles to Bernard. Okay, so with Ahmad give away means you must add back 25 for Ahmad. So here plus 25. And Bernard will minus 25. Okay, and so Ahmad at the start will be 98. Bernard at the start will be 104. And Charlie at the start will be 38. Okay, this is the start. And this is the end. All right. Okay, so the question asks for how many marbles did Ahmad have at first. Okay, so Ahmad will be this one, right? Okay, so this will be the answer. Okay, the answer will be 98 marbles. Okay. Okay, other than using this method, I think other than using tables, I believe some students, they like to draw models. I mean, there's nothing wrong with that. All right, you can do that also. In fact, after this lesson, you can actually try to use model to solve this question. But I find that using this table is much more clearer, right, to find the number of marbles. So once again, this is working backwards, right? Working backwards is when you have a final condition and you want to find the starting. Okay. Okay, now let's go through, I think we still have time for one more, right? Okay, let's go through one challenging question, okay? This question, I think I found it in one of the school past year paper. Okay, and many of my students can't do, so that's why I put as a challenging question. All right, so let's go through this question, okay? Okay, Bernice has some of money, okay? You don't know how much is it? She gave 2/7 of her money, okay, gave, right? And another 105 to her parents. Okay, so she gave 2/7 and another 105 to her parents. Okay, and now she gave 4/9 of the remaining. Okay, I've bold these words already. All right, this is a keywords of the remaining. Okay, I think you know, right? Of the remaining means is of the remainder, the leftover. It's not the total. All right. To her sister, after giving all this, she had 1/3 of her original. Right. I've also bold these words. So one is remaining, one is original. Okay. Amount of money left. All right. And the question asks for how much did she have at first? Okay. At first. So how do you do this question? Okay. Maybe I can draw a model first to let you all have a better picture. So let's draw a model over here. Okay, this is the amount of money that she have at first. Okay, so she gave 2/7 away. So from here, 2/7, she gave away. And another 105. Okay, so she gave 2/7 and 105. So this is the leftover. All right, this is the remainder. Okay, and out of this remainder, she gave 4/9. Okay, 4/9. Maybe let me write down here 4/9 of remainder. To make it more clear. Okay, and this is the leftover, right? The leftover is a 1/3 of the total or original. Okay, this is a 1/3 of total, right? So take note, this 1/3 and this 4/9 is different. Huh? This one is of the remainder over here, and this 1/3 is the total. Okay, the total. All right. So how do we do this question? Okay, first of all, we find what is the remainder over here. You take 1 minus 4/9 to find the leftover, right? The leftover here. So you take 1 minus 4/9, right? You get 5/9. Okay. All right. So this one is 5/9. And this 5/9 will be the leftover here, right? So from here, we can see that 5/9 of the remainder right, will be equals to the 1/3 of total. You get what I mean? Because I've already taken a 1 minus 4/9, so this is actually 5/9 of the remainder, right? So 5/9 of the remainder will be equals to 1/3 of the total. Okay, so I want to find a remainder. So this is what I do, right? I divide by 5. So here must divide by 5 also. All right, so 5/9 divided by 5 will be 1/9 of the remainder. And 1/3 divided by 5 is 1/15 of total. Okay, but I want to find the total remainder, right? So what must I do? I must times 9 over here, right, to get 1 whole of the remainder. Okay, so 1 of remainder, or 1 whole of remainder. Okay, so here must times 9 also, right? Okay, 1/15 times 9. So 1/15 times 9, you will get 3/5. Do you get what I mean so far? All right, so what does this mean, right? It means that this whole remainder, okay, can you see my cursor? All right, this whole remainder, the whole of this remainder is equals to 3/5 of the total. In other words, okay, let me redraw the model over here. So this is the total amount of money that she have. The remainder is from here. Right, this is the remainder, right? And this remainder will represent 3/5 of the total. Right, because the remainder, right, one whole remainder is equal to 3/5 of total. And at the start, she gave away 2/7 of the total, right, to her parents, and another 105 over here. Okay, so to find the 105 over here, right, this is what you do, right? You take 1 whole minus away these two fractions. Okay, minus the 3/5 and minus the 2/7. Okay, so you take 1 whole minus 3/5 minus 2/7. Okay, to find the leftover fraction. Okay, and you will get, if you press your calculator, you will get 4/35. Okay, that means this 105 represent 4/35 of the total. All right. Okay, once again, you can double check. You can take 3/5 plus 4/35 plus 2/7, right? You should get back 1 whole. Okay, so from here, we see that 4 units will represent 105. And what do they want, right? They want the amount of money at first, right? At first will be 35 units. Okay, 35 units over here. So 35 units will be 105 divided by 4 times 35. Okay, so the final answer will be 918.75. Okay, so this is the final answer for these challenging questions. I hope that you can understand this. Okay, maybe let me scroll to the questions in the chat box over here. Let's see if you can understand. Yes, for Anon, yeah. Constant total means one quantity remain unchanged, the same thing. I mean constant part, right? Constant part is one quantity remain unchanged. Super lemon candy. Okay, that's out of the point. Okay, any other questions that you all have? Clicking sounds? Oh, is there clicking sounds? Oh dear, I'm sorry if there's some clicking sounds in the background. I think it's because of my pen over here, or I think a bit too hard. So please bear with it. Oh yes, branching method. Yes, of course, you can use the branching method to solve this challenging question. Right, no problem. Okay, but of course, you need to know, you also need to convert the remainder to the total, right, in order to use the branching method. Okay, for those who know the branching method, yeah, you can go ahead to do that, no problem with that. All right, so these are the problem sums that I've covered today. Okay, so we have gone through model drawing. Okay, model drawing. All right, we have gone through constant part. Constant part is when one of the part remain the same. Okay, we have gone through constant total. Constant total is when you have an internal transfer. Okay, we have gone through grouping, right, where you need to group things up, and from there you can find a total number of groups. Okay, we have also gone through guess and check, which I have shared with you another method by using assumption. You suppose something, okay, and then you use this concept called big gap over small gap, right, to find the answer straight away. Okay, and we also went through this method of working backwards. All right, using a table to represent the working. Okay, so in your exam, all right, where you read the problem sums, all right, most likely you will be using a few of these methods, right? Sometimes it can be a few methods together in one question. All right, so when you read the question, you must first of all understand the question and identify the method that you want to use. All right, that's very important, right? Because once you are able to understand and identify the method, right, you're halfway through solving the question already. Okay, so I'm going to go through some common mistake that you should avoid. Okay, of the remainder, all right, this one I went through just now. Of the remainder is not the same as of the total. Okay, so please keep this in mind when you do your exam. All right, when you see of the remainder, it means it's of the leftover, right? It's not of the total. So you may need to convert the remainder to the total. Like for example, in this question, I convert the remainder to the total. Okay. Okay, increase to and increase by, right? This is another, I think this is playing with English, okay? Unfortunately, nowadays, maths, they like to twist around with the English words. All right. So, all right. So you need to understand how to the difference between increase to and increase by, right? Increase to means you are given the final value, okay, and increase by means you are given the difference, right? Which increases by. All right. So for example, if I say increase to 20, it means that 20 is the final value, right? And if I say increase by 20, okay, this 20 is the difference, right? That means the value that it increases. Right, so please take note, right, between these two words, increase to and increase by. All right, so the next common mistake is 20% off and 20% more than. All right, this is once again, right, keywords here. 20% off means 20% of the total. 20% more than. Okay, what does 20% more than means? When you have 20% more than, it's the same as 1/5 more than, right? Because 20% is the same as 1/5. Okay, so what it means is if the total, I mean, if the start at the start is 5 units, 1/5 more than means you have 6 units at the end, right? Because you have 1 unit extra. Okay, 1/5 more than. Okay, this is called 20% more than. While for 20% off means total there are 5 units, and you only have 1 unit, right? Right, this is called 20% off. Right, so please keep in mind. All right, these are the keywords. 3 times as many as and 3 times more than. Right, the same thing. Okay, 3 times as many as means you have twice of the number. 3 times more than means you have 4 times of the number. Do you understand? Okay, let me repeat that again. 3 times as many as means if A is 1 unit, B will be 3 units. While 3 times more than means if A is 1 unit, B will be 4 units, right? Because 1 plus 3 is 4. Okay? All right, so these are some of the common mistakes that you should avoid when you read the question. Okay, I'm going to go through some final tips before we end this lesson. Of course, I'm sure you heard this before many times, right? Easy one first, tough ones later. Tough ones later. So when you meet questions that you can't do, all right, always spend the most, I would say, 1 or 2 minutes to think through first. If you really have no idea what to write, right? If you have some idea what to write, just write down the working first, okay, and think again, right? If you totally have no idea what to write, how to start, you may want to skip first and do the rest, right? To do the easy one first, then you come back to the later one, right? This will save you a lot more time. Okay, look through the paper first when you receive a paper, right? When students get a paper, the first thing they do is they started doing. I think if you can scan through a paper first, you don't have to spend too much time. Maybe just spend around 20 seconds, right? That's not a lot of time, right? To look through a paper first, and by looking through a paper, you can have a feel of how much time to spend on each questions. Right. For example, if you see drawing, right, the problem sums at the back, you know that you had to spend more time on those questions. So at the start, you may need to hurry up. All right. Okay, always check your answer. Yes, this is one of the most important tips I can give. All right, because a lot of students lost marks due to careless mistake. Always check your answer towards the end. Right, you should give yourself. I mean, of course, the best will be as much time as possible, but at least, hopefully, you have at least half an hour in the end to check your answers. Okay, how to check your answers? All right, there are a few ways. Okay, I found a very useful way is to write the working clearly. Okay, so that you are able to check your answers better. Okay, show step by step. You'll help you checking the answers. And for questions like, maybe let me scroll back. For questions like, in this case, the guess and check. Okay, to check the answer, very simple. You simply take, okay, how to check the answer? Okay, you simply take 20 times 65 cents plus 28 times 50 cents. All right, you should get back the total amount of money, right, which is $27. Okay, this is how you double check the answer, right? I think this is the most fastest way to check the answer. Okay, of course, other than that, for this question, those end of exam, please press the calculator again and make sure that you got no careless mistake when you do your plus and minus. I think that will save you a lot of marks also. All right. Okay, and please do not skip steps. Show all the workings clearly because there will be working marks given. All right. I know some things are very obvious. Like for example, 2 units is 24. Some students just straight away, just straight away write the final answer now without showing the working. Right, but please show the workings like this, right? You want to find 3 units, you'll be 24 divided by 2 times 3. Okay, don't straight away just give the answer like that. All right, and yeah, you need to show the working as clear as possible because remember you are showing to the marker. If the marker don't understand what you're writing, right, the marker will not give you the marks. Okay, so do slowly, do step by step, all right, and make sure that you are very clear in all your workings. Okay, and finally, okay, presentation is very important. Okay, as you can see, when I do my problem sum just now, all right, I show all my presentation clearly. I do not skip any steps, and it's always good to write words, right, to beside the numbers to represent what are what does this value stand for. Okay, so for example, all right, let's say you have 20. Example, this is your working. 28 minus 2 is 26. Okay, you may want to put down the words here. Rate stems at first. Okay, all these are very, very useful. I feel that because in the end, when you check answers, right, you'll be able to know what does the 26 stand for. Right, if you don't write this, right, later when you come back to the question, you will wonder yourself, why did I put this 36? How did I get this 36? Right, so if you write these keywords here, you'll be able to understand your working very, very fast. Okay, so that's the end for my lesson today. Well, just nice. It's 9:30, 9:32. For those who are taking their, I believe most of you are taking a PSLE next year, right? I hope that you can join our gang. Okay, you can join our gang by clicking on the link right given in our website, the yellow button over there, to find out about our schedule. We have 2 classes. Okay, one is Saturday and one is on one is on weekday. Yeah, you can check out the schedule in the website. Okay, so do check out I think for the study class, you only have a few spaces left. For my maths class, I only have 1 space left. Okay, so if you are interested, please call our hotline. All right, 6280-6841. Okay, to find out more about our schedule next year. All right, if you can't, if the weekend class is full, you can always feel free to join the weekday class. Okay, the schedule once again is given in the website. Okay, and for those students who stay too far, because our center is located near Kovan, all right, near our Hougang area, we actually have an online tutoring website. Okay, it's called tutornotes.com. You can actually find me on this website. Okay, lessons will be conducted online, similar to this. All right, but I can teach you live, and you can actually talk to me and ask me questions online also. So feel free to check this website if you need to. And last but not least, right, if you need more explanation on the methods which I covered just now, of course, those are only a few of them. In total, there are 8 methods, master methods. You can check out my online course, right, in this link here. Okay, so that's it. All right, take care and good luck. And I wish you all the best for your exams.